Turning our attention to the Arctic, we can examine the impacts of rising land and ocean temperatures on the melting of the ice caps. The Arctic is defined simply as the area north of the Arctic Circle, which is roughly 66 latitudinal degrees above the equator, and this region is especially vulnerable to changes in global temperature because of the extensive amounts of snow and ice that exist here. A critical threshold exists at 0 degrees Celsius, and any deviation above this threshold has the potential to drastically transform a given landscape, which we have already begun to see. Land surface temperatures have increased more than twice as fast than the global average, at a 1.08 degrees Celsius since 1990, and surface and deep sea temperatures in the Arctic have increased by about 0.09 and 0.5 degrees Celsius respectively. This equates to shifts in energy transfers throughout the cryosphere, directly affecting amounts of snow cover, atmospheric humidity, wind patterns, cloud formations, and ocean circulation. For instance, ice thickness declined nearly 1.3 and 2.3 meters between 1980 and 2008, and the number of days between spring melt onset and refreeze has increased by a minimum of 5 days per decade since 1979. These shifts within the system could also be due to natural variability among these factors, but further studies have concluded that the observed changes to date cannot be explained by natural factors alone. As such, cities and settlements within the Arctic Circle are especially vulnerable to rising oceans and ecosystem collapse. Iqaluit, Canada, is no exception to this threat, as the growing population faces difficulties constructing homes on thawing permafrost. Rising land, surface, and ocean temperatures have resulted in rapid melting of the ice, and precipitation patterns have resulted in more snowfall in this region of the circle. Ironically, this is bad for the permafrost, since the snow acts as a blanket to the ground, insulating heat and keeping ground temperatures warmer than those of the air. To enable construction in the face of thawing permafrost, easy-to-assemble housing units with super-insulated walls, built composting waterless toilets, and wooden skids that enable dragging across the permafrost when necessary are at the forefront of structural development within the Arctic Circle.